Hi everyone, welcome back to the GCSEMathsPro YouTube channel. In today's live, we'll be going through the June 2019 paper 2H, so the higher tier paper from Edexcel. Make sure that you do have your calculator with you so that you can practice it, obviously with the correct calculator, not with your phone calculator. I have linked this paper and the mark scheme in the description as always, so you can open it there, or if you want to look at the mark scheme as well, then obviously you can check that as well afterwards. So let's make a start on this one then. So question 1, we have part A is to solve 14n is greater than 11n plus 6. We obviously just want to solve this like a normal inequality, a normal equation even. You can just keep the same symbol but treat it as an equation. We want to get n together on the same side. So I'm going to move the 11n because that's a smaller amount and I want to have a positive n. So if I subtract 11n, I get 3n is greater than 6, and then if you divide by 3, obviously just like a normal equation, you get n is greater than 2. Yeah, I'm doing really well today, guys. Thanks. How are you guys? Are you ready for paper 3? Or at least are you ready for maths to be done? That's more so the question, I think. Part B, on the number line below, show the set of values of x for which -2 is less than x plus 3, which is less than or equal to 4. So they've given you a bit of space here as well, obviously to draw it, but a little bit of space as well, I guess, to work it out. And it is 3 marks because, do you see how the centre here of the inequality is x plus 3? And then on the number line, it's just x. So we have to just solve this equation, well, this inequality first, before I can then start drawing anything on my number line. So you just do it the same way as you do any other inequality, except now we've got 3 parts that we're going to be, in this case, subtracting 3 from. Obviously, we want to subtract 3 from the middle because that will get rid of the 3, just leave us with x. But you have to do it from all sides. So subtract 3 from -2, so that's -5, and then obviously from 4, that's 1. So this is actually what we're going to be showing on the number line. Yeah, vector circle theorems. On this paper that we're doing today, the last question is a really hard vector one, so that's a good one we can at least practice. Okay, so then obviously you draw a circle on each number, so -5 and 1. The 1 we're going to colour in because it says less than or equal to 1, so it could also equal 1. And if I just get my ruler, draw a line just straight between them. My predicted paper 3 will release on Monday, for anyone asking. On the grid above, draw the graph, even, I was about to say line, but it is a line. Draw the graph of y equals 2x minus 3 for the values of x from -2 to 4. So they've given you a bit of space. If you want to, you can obviously set up your xy table. -2, -1, 0, 1, 2, 3, 4. And then I would probably just do this on my calculator, to be honest, given that obviously it is a calculator paper. So I go to mode, this button here, yours might be called menu, it might be in a different place because obviously my calculator isn't likely to be the same, but some kind of mode or menu option. For mine, number 7 is table. You might have a different number, but hopefully you've got an option obviously for some form of table. F of x represents y. It's just interchangeable, isn't it? So they've said y equals, we just type the rest. So that's 2x minus 3. It's given me another option for a second graph, but I don't want one, so I'm just going to ignore that. And then start value is the start of your table, so -2. I'm just writing it on top, if that makes sense. End value is 4. The step means the difference between them, so normally that's just 1, isn't it, anyway? And then you get a vertical table, so you just have to kind of translate it across. So where it's -2, we get -7 for y. -1, -5 for y, 0, -3, you get the gist. So -7, -5, -3 for the first ones. You could also just start out by finding the first value and then adding 2 every time if you want, because can you see how the gradient is +2, so every time the y will go up by 2. So you could also do that if you prefer. -1, 1, 3, 5. Okay. That's meant to be a -1. And then obviously you just plot it. It's pretty straightforward from there, isn't it? Obviously it's linear. It should create a straight line. If it doesn't, then something has gone wrong. Five. Get your ruler, draw a line through it. And there you are. This is paper 2. I don't know anything about if there can be one hard vectors or hard circle theorems. I don't know. Don't know if that's true or if that's just like something that's circled around from students. I'm not sure. Yeah, I realize you've done paper 2 already, but there's no like topic list for only paper 2 and only paper 3. The topics are all the same, and every year they mix between them. So that's why I'm still doing, we're just focusing on doing calculated papers in general. I know that some of these topics, obviously by now you would have covered anyway. There are also students here who are in year 10 as well, so it's still helpful to them. But yeah, it's paper 2 and paper 3 aren't explicitly split between 2 lists of topics. It's a whole mixture. So if you're revising paper 2 or paper 3, you should revise both. Our next one will obviously then be the paper 3 for this year anyway, so that's fine. Okay. I'm just checking the comments. Okay, question 3. So Hannah is planning a day trip for 195 students. She asks a sample of 30 students where they want to go. Each student chooses one place. So the table shows information about her results. You can see we've got places: theme park, theatre, sports centre, seaside. Obviously then the number of students for each. So that's our 30 students there. Work out how many of the 195 students you think will want to go to the theme park. So this is obviously like a sample kind of representation situation. So the theme park for the sample was 10 students out of 30. So we're going to assume that this same kind of portion, this same fraction of the students would apply to the 195 as well. So you just literally multiply it. It's effectively a third of 195, isn't it? 195 divided by 3. So you should get 65. Now, part II, state an assumption you made and explain how this may affect your answer. So what I was saying is I made the assumption that the sample was representative of the whole population. So I would say there's multiple answers for this. I'll show you the mark scheme in a minute. But I normally with this question go with sample representative. Sample is representative. Try and make it at least slightly coherent. Representative, I can't even spell it. There we go. Representative, there we are. So that's my first bit. That's the assumption I made. How would this affect my answer? So let's say, imagine if the sample wasn't representative, then my answer would be, you could either say it's wrong or different, isn't it? Because basically, if the sample's not representative, we don't know how it's not representative. So I couldn't really say my answer would be less or more. I can't really be that specific. I would just say that my answer would be wrong or would be different. Something like that would be the reason or how it would affect. So let me grab the mark scheme just so you can see a few of the worded answers, because obviously there's multiple suggestions that they had. So you can see here, sample is representative, otherwise answer is wrong. You could say your assumption was it was a random sample, otherwise the answer would be different. Your assumption was that the 30 students are from the 195. Because obviously if you just took 30 students from a random other sample, then that's completely irrelevant, isn't it? Otherwise it wouldn't be accurate. 10 out of every 30 students want to go to the theme park. That's kind of the same wording as representative, but without using the word representative. Otherwise, answer will be different and wrong. There is no bias, that kind of thing. yeah, you can see here there would be more than 10 people. Like, we can't really assume less or more because we don't know to that much detail. Can you say the other 105 will like the same as the... Where's the 105 come from? What do you mean 195? Just checking where the 105 has come from. Oh. The other 195, yeah, 195 subtract 30 would be 100 and... Oh, okay, that's what I was gonna say. Yeah, that's fine, 165. Can you say the other 165 will like the same as the 30? I don't think that makes sense now. To be honest, I don't think that makes sense. Normally when it's a sample, I normally stick with sample as representative, or what was the other one they mentioned? Random sample or something. I think the representative one, at least for me, that one's the most obvious because it's like you've got a small portion and you're applying that portion to the whole thing. So you are literally assuming that that portion is, you know, represents, or that portion speaks for the rest of the population as well. And that's normally what I go for if you get some kind of sample question. To be honest, I would stick with that. Yeah, I don't think... yeah, let me read it again. The other 165 will like the same as the 30. Well, I guess you're saying, like, in other words, I guess you're saying it's representative, right? That's kind of what you're getting at. Yeah. Did you word it exactly like that? The other 165 will like the same as the 30. It's a bit vague, but maybe. It's the same reason as the representation reason, isn't it? Just worded differently. Maybe. It depends also what you said as your therefore bit, the bit after, because you only get 1 mark for both pieces as well. Oh, you expanded it a bit more, then yeah, maybe. If it was, yeah. Yeah, maybe. Also, if you've obviously had to put the reason, like how it would affect your answer as well, to get just 1 mark. Okay, question 4. A container is in the shape of a cuboid. The container is 2/3 full of water. A cup holds 275 milliliters of water. What is the greatest number of cups that can be completely filled with the water from the container? So this is obviously just volume, isn't it? So volume of a cuboid is pretty nice. Just multiply all the sides together. 30 times 6 times 19. Which gives you 3,420. Now, the only things to remember is that it is only 2/3 full. So they've added that in because I feel like it's quite easy to forget that. So 2/3 we want of the 3,420, which actually gives you 2,280. So that's actually how much water we have. Now we want to know, because they obviously that's in centimeters cubed, isn't it? This is in milliliters. Centimeters cubed to milliliters is the same. So as in 1 centimeter cubed would be 1 milliliter. So it's the same. So all I need to do is to work out how many cups it would hold. How many cups of water is literally just divide it. I don't need to convert anything. I can divide it straight away. So let me just show you. Oh yeah, if you want to get out of your table function, you have to press the same menu mode option and just choose whatever the original one was. So you can see here, I get 8.290909 ... So I need to obviously round it. You're either going to round up or down, but it says, it depends on the context, doesn't it? So it says, what is the greatest number of cups that can be completely filled? So completely filled would only be 8, wouldn't it? Completely filled would only be 8. I'm just pausing because I think my thing reloaded. Hopefully it's not breaking up for you. Yeah, so it'd only be 8 cups because technically we can fill 8.29 cups, but obviously that 2.29 cup isn't full, is it? 8 cups. Hang on, let me check the question. Do I not do 3? No, because... well, no, because they're asking how much is full, aren't they? Yeah, guys, let me know if the live is loading or not. Check what Wi-Fi I'm on. Yeah, I was on the wrong Wi-Fi. Is it working now? It's going green now. It was red before, now it's showing me green, so hopefully... Yeah, okay. Yeah, so what I was saying about your question was because they've asked... You're focusing on the bit that's empty, but it was only asking for the bit that was full, wasn't it? It wasn't asking about the part that was empty. So, because we know 2/3 of the is full of water, I want to know how much water is actually in the container. That's this much water, isn't it? That's how much water I have. Therefore, how many cups can I fill up with that water? It's not really anything to do with what's empty. It's to do with what's full, isn't it? So that's why I haven't subtracted it. I've just worked out the 2/3 straight away. That's how much water I have in total. Okay, but then how many cups would that completely fill? Only 8. And that's a 4-mark question, yeah. So 8 would be your answer. Yeah, just double check the question, exactly. Question 5, so ABC is a right angle triangle. Calculate the length of AB. So this is obviously just normal trig, isn't it, SOHCAHTOA? We want to know the opposite. We've got the hypotenuse, so that tells me that I need to use sin. So my actual calculation, because I'm looking for the opposite, would be sin 38 multiplied by the 16. $16, and then they said 2 decimal places. You can see that rounds quite nicely to 9.85. So yeah, nice 2 marks there. That one's pretty straightforward. Question 6, Sally used her calculator to work out the value of a number y. The answer on her calculator display began 8.3. Complete the error interval for y. So this one is the version, I don't know if you've heard me talk about error intervals before. There's 2 versions of error interval questions. It's either going to be some kind of rounded one where they've rounded it to 1 decimal place or 3 significant figures or like to the nearest meter, or you know what I mean, they've rounded it. In which case it's the same as upper and lower bounds. But this one is not the same as that. This is not the same as upper and lower bounds. You don't want a little bit less and a little bit more. The reason being is because imagine your calculator display. Sally has looked at it and she has physically with her eyes seen that it says 8.3 something. So if you get one like this where it's either a calculated display question or they might use the word truncate or truncating or truncated or whatever. That's the same. This is the other option. It's where they've taken a number after a certain amount of digits, they've just chopped off the rest. So they haven't cared what came after 3. So if you get this scenario, the smallest one is always the number they give you because Sally 100% saw 8.3. So it can't be less than 8.3 because she saw it, didn't she? She physically read that off of her calculator. Now, we don't know what came after the 3. It could have been, well, they wouldn't have obviously written zeros if it was, but it could have technically had zeros after it, couldn't it? Or it could have had 9s to infinity. We don't know what came after it. So the smallest it could be is the number that they've actually seen. The biggest it could be, well, is technically 8.4. Now, again, I know it can't be 8.4. Like, she obviously didn't read 8.4, but that's why we've got these inequality symbols here. We're saying it could have been 8.3 literally, as it is on its own, or more, up to the point of 8.4, but not including 8.4. So that includes the 8.399999999 forever scenario. That includes that. So it's anything between 8.3 and 8.4. Yeah, so truncated is just where they look at a number and after a certain number of digits, they can choose how many digits depending on the question, They just cut off the rest. It doesn't matter. So they haven't rounded it, right? They haven't, you know, obviously if you got 8.39 and you said round it to one decimal place, you would obviously round it up, wouldn't you? But with truncating, you don't. You just go one decimal place. Okay, that's 8.3. I don't care what came after it. Yeah. So that's the different scenario. Obviously, the one where it's rounded relates to upper and lower bounds. So yeah, you do a little bit less, a little bit more. The one where it's truncated, or in this case, the calculator displays the same logic, you have to do the number that they give you as the smallest, and then whatever it is, one more. Do you see how, because it was to one decimal place, I did one decimal place more? Yeah, 8.25 and 8.35 would be upper and lower bounds. That would be correct if the question said rounded to one decimal place. But it didn't say that. It said, well, it didn't even say truncated, but the logic was that it was truncated. They just read off the first two digits and they ignored everything that came after it. They didn't round it. So yeah, yours would be for bounds, yeah. Okay, question 7. £360 is shared between Abby, Ben, Chloe, and Dinesh. The ratio of the amount Abby gets to the amount Ben gets is 2 to 7. Chloe and Dinesh each get 1.5 times the amount Abby gets. Work out the amount of money that Ben gets. So just a general kind of worded one, bit of ratio here. This is one of those ones where there's definitely different ways to go about it, but what I thought of doing was just creating a big ratio, as in a 4-part ratio. We obviously know Abby is 2, Ben is 7, but we know the link between Chloe and Dinesh and Abby, don't we? We know that they get 1.5 times the amount that Abby gets. So what I did was I said, well, if Abby gets not £2, but 2 parts, and they get 1.5 times that, that's just 3, isn't it? And they both get the same, 3 and 3. So that's how I worked it out. Obviously then, all I need to do is just share out the ratio. So if you add it up, you get 15 parts. 360 divided by 15 is 24. So they get 24 each, and then they've only asked for Ben. So I only care about Ben. I don't really care about anyone else. 7 times the 24. And that gives me 168. Yeah, exactly. Now, as I said, you might have done it a different way to me. That's absolutely fine. If you've got 168 at the end, then I would assume that we'll all get the marks. That's fine. Question 8, we have standard form. So write 0.00562 in standard form. So this one, I'm just counting how many I'm going to move the decimal place by. 1, 2, 3. It has to obviously go between the 5 and the 6, doesn't it? 5.62 times 10. Now I've moved it 3 times, but the original answer, the original number was smaller. So that's a -3, isn't it? 10 to the -3. This one, you can obviously type this into your calculator as well if you want, but again, I'm just going to move it 1, 2, 3. It becomes 1,452 as an ordinary number. So that one's pretty straightforward. Question 9, the circumference of circle B is 90% of the circumference of circle A. Find the ratio of the area of circle A to the area of circle B. So this is, I think you had a question on this topic anyway, or something similar to it. So whether they'll ask it again, I don't know, but the circumference, don't necessarily think of it as a circle as in pi r squared or anything like that. Don't worry about that. Just think of it as a side length or some kind of one-dimensional measurement, which is the circumference is a side length, isn't it? Just one dimension. The area is 2D, and then if they ask for volume, that's 3D, for example. So the circumference, I would write a ratio, A to B. When you don't have numbers, you can choose 100. So for example, A would be 100, B would be 90. Yeah, I think you had a question similar to this. I don't think they'll ask it again, but just to show you. That would just simplify to 10 to 9. I'm just going to simplify it like that. Then the area, all I want to do for the area is just think, because we're using ratios here, we're not actually talking about literal values, are we? We're just talking about ratios. So how do I go from the circumference, which is 1 dimension, to the area, which is 2 dimensions? You just square it. Okay, so that would be 100, and that would be 81. That's what I would put, literally. Just think, Square it to make it area. If you need to make it into the volume, you cube it. If you need to go from the area back to the side length, you square root. You get the point. Just think of it like that. Don't try and use any actual formulas for circles or anything. That's not relevant. Normally I would call this surface area to volume ratio, which I know there's no volume here, but like that's generally the topic. What topics do I think are going to come up? Yeah, I know. I said don't think about any equations. Just think about it really basically and think circumference is a one-dimension measurement, isn't it? Same with perimeter. It's one dimension. Area is 2D, so you square it. Because we're not talking about actual values, are we? We're not actually. They haven't told us what the circumference is. We're just looking at a ratio. So this is just how it works. Topics that I think would come up: compound interest. I think speed, distance, time at some point, whether it's an easy one or a hard one, I don't know. Error intervals we haven't seen yet. Obviously, you've already mentioned vectors and circle theorems we haven't seen yet. I don't think you've seen simultaneous equations yet, but correct me if I'm wrong. I don't remember seeing any simultaneous equations. We haven't had quadratic sequences that might come up. Graph transformations. I guess you kind of had a graph transformation one, the one with the circle, but not like explicitly graph transformations. A hard speed distance question, I think I've seen them mix it with upper and lower bounds, so they just make it harder. Or maybe if they mix it with bearings. It's when they mix it with something that makes it, harder. Mix it with another topic. Yeah. Those are kind of the main ones. Maybe trigonometric area of a triangle. I don't think you've had that. I don't think you've had many... did I say upper and lower bounds? I can't remember if I said that. I don't think you've had like a big algebraic fractions question. That could be possible, maybe. Beyond that, those are kind of the main ones. Beyond that, I was thinking a Venn diagram one, maybe. I mean, obviously, they might throw in bearings, mightn't they? They might not. That doesn't always come up. Cones, spheres, one of those you haven't really seen. The volume or the surface area. Maybe area of a sector, that kind of thing. 1D and 2D, yeah, I mean 1 dimension. So you see how, let's think about the circumference. Let's imagine the circumference would be in terms of centimeters. Let's imagine that it was centimeters. The area would therefore be in terms of centimeters squared. This is technically centimeters to the power of 1, isn't it? I know we never write that because obviously that's irrelevant. But that's what I mean. It's 1 dimension, isn't it? Because the circumference is just like a line, isn't it? Whereas the area is the area is an area. That's not really a very good way to explain it. That's what I mean by 1 dimension and 2 dimensions. So see how this one is just to the power of 1, this one is squared. So I take my ratio for the circumference, or whatever your 1-dimensional measurement is. It could be a side length, could be a radius, could be any kind of, as long as you know that the units would just be like centimeters, that's 1 dimension, isn't it? And then area is centimeters squared, so you just square it. Don't they say that you can ask for more paper if you run out of space? I'm pretty sure they would have told you that, no? There's blank pages at the end of your paper, but it normally says do not write here. So if it says don't write here, you won't get any marks because they won't mark it. I think you have to ask for extra paper. But again, surely they would have explained this to you at the start of your exams. Like when your invigilators are starting the exam, they'll read out the rules, they'll tell you what happens, that kind of thing. If it says do not write in this space, obviously don't write in that space because they will not scan it, they will not mark it. Yeah, if you ask for extra... Yeah, if you ask for extra paper, that's what I would say. I mean, to be honest, I never ran out of space when I was doing maths, so I don't know, but... yeah, you should be able to ask for extra paper, for sure. Okay, part B, so now we're looking at squares. Again, don't think about it in terms of an actual formula, just think, is it 1-dimensional, 2-dimensional, that kind of thing. So square E has side lengths E, and square F has sides of length F. The area of square E is 44% greater than the area of square F. So again, I'm going to put a ratio E to F. We're obviously in this case starting with the area, aren't we? So they haven't given you numbers, so start with numbers. E is greater, so let's give the 100 to F. E would therefore be 144, wouldn't it? Now, hopefully you can recognize these numbers. These are both square numbers, and that is deliberate. So because that's 2D, if I want to find a side length, that's one dimension, isn't it? So do you see how now I'm going backwards? That means I need to square root it to make it from 2-dimensional back to 1-dimensional. So that's 12, and that's 10. You can put that, they haven't said to simplify it. It does obviously simplify to 6 to 5, but they will allow any version of that ratio because they haven't specified. Where it says blank page, no, you can't write on that. Yes, this is a paper 2, as it says in the title. Guys, you can't write on any paper unless they've given you extra paper, okay? Do you see how it says here, like, do not write in this area, that kind of thing. Do not write anywhere. Because otherwise, like, they're not going to mark it. And then there's no point, is there? Let me see if I can find it, because I don't think this one has any extra paper at the end, but see if I can find an example that has extra paper at the end. Yeah. So like this one, for example, this is a different paper. This is your last question, right? It says total, that's the end of it. This blank page, you're not supposed to write on this. It's not there for extra writing. Right, I'm pretty sure you have to ask them to give you extra paper, and then they give you a sheet of paper that they connect to your exam. Because I don't think they're going to mark this. I don't think they're going to... I'm pretty sure they scan them all in and send them to whoever they're going to mark them. I don't think they would scan this. So don't write anything after it says the total. Okay. I don't know. Maybe it's to. It depends on how many, because you know how you have different questions and how many actual pieces of paper it makes. Maybe it creates the booklet, and some exams end up having the booklet with the final question on the final piece of paper. Some of them maybe have either fewer questions or the pages that the question took up were less, so they then have like a gap at the end to balance it, you know, like to make it into a booklet. I don't know, but you're not supposed to write on there. Hence why it says blank page. It doesn't say page for extra working. So question 10, Mary travels to work by train every day. The probability that her train will be late on any day is 0.15. Complete the probability tree diagram for Thursday and Friday. So because we've only got enough information that it's late on any of the days, then this is not conditional probability. It's just 0.15 for all of the lates. If they don't give you enough information, then you can just take it as that it's going to be the same probability for all of them. You know, if it wasn't the same probability for Thursday and Friday, they would specify, which they haven't. So we're just copying all the numbers here. Yeah, not late is 0.85 exactly. Yeah. So that's the first 2 marks. Then you've got part B. Work out the probability that her train will be late on at least one of these 2 days. So this one, there's actually 2 ways to do it. You could highlight the options for at least late on one of the 2 days. So late, and then it could be late again, couldn't it? Because it's at least one. So it could be both. That includes both. Obviously then it could be late and not late, or it could be not late and then late. Now you can obviously work out all 3 of these if you want, and if you feel kind of confident enough. What you can do is identify that the only thing that isn't included is the not late and not late, isn't it? That's the only scenario that's not included. So if you want to not bother working out all 3 of these sections or different options, what you can do is just work out the option that is not included, and then you'd have to obviously do 1 minus that. So you can do either of those, it's up to you. When we're working with probability trees, we always multiply between the branches, so I'm just going to do the long method, but well, I'll show you both. Technically the other option is 1 minus 0.85 times 0.85. That's the other option. So 1 minus the late, not late. So late would be obviously 1.5, no. 0.15 times 0.15, then you've got 0.15 times 0.85, and technically this other one is exactly the same, just the other way around. And then if you've got multiple options, if you do it this way, if you've got multiple options, then you add them. So just type it all in. And we get 0.2775. And I'll show you that the other one also gives you the same answer. 775. I would just write down all those decimals because there's not that many, is it? The other option, if you see, look, you can do this. Do you see how you get the same answer? So it's up to you whichever way round you want to do it. Yeah, there is adding, but it's not between the branches, is it? If you have to add, it's only if you've got more than one scenario. You add at the end. But between the branches, it's always multiply. Yeah, at least is a minimum. Exactly, a minimum. So one late or more. So that's why I also included both late. Exactly, yeah. All of them has late in them except for that bottom one. So these two are just two different options, right? It's this one or this one, right? You don't have to do both. It's just I'm giving you two options for how you want to work it out. Obviously, I know I've written up there. You would write all of your working down here. I'm just doing it up there so that you can see it all in one page. Do I think advanced vectors are likely to come up for paper 3? I mean, there's definitely a good chance, isn't there? Because you haven't had it yet. Definitely a good chance. I can never say for sure, but yeah, I think there's a good chance for sure. But this paper actually has a vectors question right at the end. So yeah, that would be a good one to go through. Do you have to write in number line? Do you mean this is the number line here? Do you mean that bit? Or I'm not sure what you mean by that. I don't think you have to. Like, if you wrote it here, they would be able to find it. But what I would do, just because you're in the exam, I think it's good practice to make sure if they've given you a space to put the answer, I would try and make it as obvious as possible. So I would put it there. Yeah, you can write the fraction as well. I just thought the decimal wasn't that difficult. What was the fraction? I think it was 111 over 400. You can write either form. You could write it as a percentage if you really wanted to. I don't know why you would, but you could. Any of those would be fine. Do you always multiply them? Yes. Between the branches, you always multiply in any... can't even remember what it's called now. Probability tree. Yeah. Okay, so what about it? If you've got two possible answers, you're not sure which, they will accept let's say one of them is correct. They will accept it as long as the other answer isn't a direct contradiction. So as long as the other one isn't the complete opposite, then they will accept it, whichever one is correct. If it is completely, if one of them is, one answer and one of them's opposite, then they will cancel it out. Hopefully that answers your question. So it depends on the question. So question 11, you haven't had cumulative frequency yet. I feel like this comes up most years, but maybe they'll surprise us this year. So the grouped frequency table gives information about the times in minutes that 80 office workers take to get to work. So you've got this table here, complete the cumulative frequency table, you just add them up. So 5 is still the same as the first one, then 35, then 55. That's why it's only 1 mark, right? Because it's quite easy. That's 70, 78, and obviously the total. So this one should equal, if they tell you in the question, the total of in the question. So that's pretty straightforward. Yeah, let's go on to the next bit. Let's see if it will let me copy this, because obviously you'll be able to see it on both pages, but in your exam, but here I can't. See if it will let me paste it. Yep, okay. So here's our table. Obviously you'll be able to see it on your page, you know, double spread in front of you anyway. On the grid, draw the cumulative frequency graph for this information. So for cumulative frequency, we don't plot the midpoint, we always plot the end value, so the ones on the right hand side. So these ones, not the midpoint. The midpoint is for frequency polygons, which is a completely different topic. It sounds similar, I realise that, but it is not the same topic. 70, 78, and 80. Obviously your cumulative frequency graph should always be increasing. If it doesn't, something has gone wrong. This is, okay. I'm going to try and draw it as best I can. Oh, that was really bad. Obviously on a piece of paper with a pencil, you'll be able to do a much better job than I can. Something like that. Part C, use your graph to find an estimate for the percentage of these office workers who take more than 90 minutes to get to work. So I'm going to draw a line at 90. Obviously from the x-axis, because that's where the minutes are, isn't it? Here, and then across to read off the cumulative frequency, because that will tell me how many people it is. So here, that's 74. However, because they said more than 90 minutes, I'm actually interested in between, obviously 80 is the total, and 74, isn't it? So actually, a lot of the time they say this more than, just double check if they've said more than, because then it would actually be the 6 people that are taking longer than 90 minutes. But they want it as a percentage. Let me scroll this down a bit. They want it as a percentage, so 6 over 80, because 80 people in total, right? So that's the fraction. Make it into a percentage by times it by 100. 6 divided by 80 times by 100, you can see is 7.5. Now, they do give a slight range of values for this one, because obviously, even though the coordinates should be all the same, your actual drawing of the curve might look a little bit different. So that's the ideal answer. 74 is kind of the ideal answer, but they've said anything between 5% to 10%, which means you would have worked out, where I worked out 74, you might have worked out 72, 76 people, and then that's another 72, 76 people, and then you would subtract. You just have a check the comments. Seeing if we've got any questions. Why did I do 80 minus 74? Yeah, so 74 people take, it's 74 people take less than 90 minutes. People take less than 90 minutes because that's this part of the curve, and this part of the curve, do you see, is between 0 and 90. So that's, do you see what I mean? That's less than 90. So then more than 90 is then this bit of the curve, isn't it? So you have to take it away. It's just how you always do this one. Okay. Right. The thing is, there are some people here who are in year 10 who are going to revise everything. That's why I'm going through everything. If we get close to, what is it, quarter to 5? Quarter to 6. If we get close to 6:30, then I'll skip to the one at the end. I have also got a video on that final question anyway. If you check my channel, I've got video. I've got a video where I made up the questions myself, which is called Vectors Ratio Scale, which goes through the exact same method. I've got also then videos on actual past paper questions, which I'm pretty sure this one probably was included in one of those. So it's either the most common vectors question, and it'll be the one at the end, which is the hardest one, or it'll be part of the hardest vectors questions, Edexcel questions. So I've got like 3 videos on it that you can have a look at as well anyway, but I will skip to the one at the end once we get closer. So question 12, OAB is a sector of a circle with centre O and radius 7. The area of the sector is 40 centimetres squared. Calculate the perimeter of the sector. So they've given us the area of the sector. We need to work out the arc length, which means we need to know the angle. So we're going to use my formula for the area of the sector, which is pi r squared, times by the angle over 360 is equal actually to 40, isn't it? I know that. So then I can just divide that straight away. So divide it by the pi r squared. And then times it by 360. I'm just doing it in one step. So your angle is 93.544. So that's this. And then we want to know the arc length, which is 2 pi r, or pi times diameter if you prefer that. I'm using 2 pi r just because I've got a radius here. Multiplied by the angle, which I now know is 93 over 360. Bring back my calculator. I've still got it here, so I can write down my answer. 2 times pi times 7 times the angle over 360. And that gives you 11.43-ish, 11.42. Now that's the arc length. I obviously want the perimeter though, so I need to add 2 7s. 2 8 plus 7 plus 7. So add 7 is 25.4. They've said 3 significant figures, so now I'm going to round it, 25.4. And that's 4 marks. So question 13, we've got algebraic fractions. This is the type of thing I mean by saying that I don't think you've had a big algebraic fractions one before, so maybe something like this might come up. So show that 6 plus, and then in brackets, x plus 5 divided by x squared plus 3x minus 10 over x minus 1 simplifies to ax minus b over cx minus d, where a, b, c, and d are integers. So when we are simplifying, I like to factorize as much as I can. Obviously, the only thing to factorize is that quadratic there. The first fraction, I might write it as a fraction, the first kind of term there, just so that when I divide, I can see it. So I'm going to factorize this, obviously x and x. We've got a plus and a minus. And we've got plus 5 minus 2 over x minus 1. Can't cancel anything so far, but that's fine. So now I'm going to actually go through with the keep flip change. So keep the first one, that's why I wrote it as a fraction. Flip the second one and change it to a multiply instead. And now you can see when I multiply them together, I can cancel out the x plus 5s. Cancel that, cancel that. Now the only thing then to do is to get the 6 as part of the fraction, because obviously they want it as one fraction, don't they? So when you're making a fraction, again, you can just put, if you ever want to make anything into a fraction, just put it over 1, and then that gives you a starting point. So the denominator is going to be x minus 2. So how do I go from 1 to x minus 2? Well, I just times it by x minus 2. But whatever you do, you have to do the same to the top as you do to the bottom. So do you see how I get this? Because obviously if you were to cancel, like simplify that, you'd get 6 again, wouldn't you? So it's the exact same thing, just with the same denominator. Then now you can add and expand and, simplify all of that. 6x minus 12 plus x minus 1 over x minus 2. Obviously collect the like terms. 7x minus 13 over x minus 2 is your final answer, and that's the formatting. Would the bottom not be 6? It wouldn't, no. It wouldn't. Yeah, to be honest, I think algebraic fractions also is only question 13, right? We're kind of halfway. It's not even beyond halfway, really. I think it looks worse than it actually is. Once you know what to do, it's actually fine. Yeah, I have also videos on algebraic fractions if you want to go through how to do it. Why won't you times 6 by the denominator? Because if I put a 6 here, if you were to simplify it like this, right? If you were to simplify it, do you see how all of it would cancel and the actual number would be 1? But the original number was not 1, was it? The original number was just 6. Yeah, whatever we do to the top, we do to the bottom, but I didn't times by 6, did I? I times by x minus 2. So that's why the x minus 2 is on the top and the bottom, but I didn't times by 6. The 6 was just already there. Do I teach in a school? No, I'm actually not an actual teacher. I'm just like a tutor. Yeah. Okay, I'm going to keep moving through so we can get to that final question. This one you have seen. I know that you already had this question in part B as well, so maybe I'll come back to this at the end. Question 15 is one that I think you might actually... You could get this in paper 3, maybe, possibly. So this is one where you rearrange. In my head, I call it harder rearranging equations. I guess that's a really weird way to say it, but I call it, it's not just changing the subject of a formula, it's the harder version, which is why it's question 15. Because, can you see how we've got 2 of the same letter in there? That's why. That's when you can figure out that it's the hardest one. So make m the subject of the formula. So what we need to do is obviously get rid of the fraction, right? Which, to get rid of a fraction, you multiply it by the denominator. So multiply by the m minus 1. Obviously then I don't want brackets either, so expand that. So fm minus f. When you have obviously 2 of the same letter, that this is the one that I want to get as my subject, isn't it? Get them together on the same side, move everything else out of the way. So I'm going to take away I'm going to minus the 3m. I'm going to add the f, just to move it. Let's put it the other way around. Doesn't really matter which way around you write it, but... So do you have isolated the m's? Now I can't literally subtract them, unfortunately, because obviously one's an f, one's 3, isn't it? So they're not like terms. So you just have to memorize how to do this. Once you get to this point where you've got the letters that you want on one side, you just factorize out that letter, because that's how it will bring it into like one format of it. You don't want it twice, do you? It brings it into one. You just have to memorize that step. Go, right, okay, get them all on the same side and then factorize out, because I can't literally subtract them because they're obviously not like terms. And then the last bit from there is pretty straightforward. You just obviously divide by that whole bracket, get rid of it. And there you are. Okay, so I think that's a really nice question, because it's always the same every time in terms of get them on the same side, factorize it, divide it. Yeah. It's literally those steps, but I think that's so easy because you just have to memorize that step. Obviously, you might start with a different kind of formatting, but the gist is the same thing, yeah. Okay, next one, question 16. I know you've had kind of straight line graph questions, but I don't think you've had perpendicular lines specifically yet. Again, correct me if I'm wrong, but I don't remember seeing any kind of actual perpendicular lines. So this is quite a nice one because it's just the most straightforward version of this question you could get. The straight line L has the equation 3y equals 4x plus 7. The point A has coordinates 3 minus 5. Find an equation for the straight line that is perpendicular to L and passes through A. So normally, obviously, any straight line, y equals mx plus c. So that's what we're trying to find out, isn't it? We want m, which is the gradient. We want c, which is where it crosses the y-intercept. Well, where it crosses the y-axis, which is the y-intercept. Now, normally to find the gradient, you want to find the gradient first in most cases. Normally, I would use 2 sets of coordinates, but do you see how in this case I don't have 2 sets of coordinates for the line, the perpendicular line? So what I have to do is therefore use the original equation for line L. So what we'd have to do is rearrange this to get y as a subject, so that's just dividing by 3, isn't it? So this is L, by the way, this is not a perpendicular line, this is L. If I divide by 3, I obviously get 4 over 3 plus 7 over 3. So the gradient of line L is 4/3. Therefore, the gradient, I'm just going to put P for perpendicular because they haven't given me like a name for that line. The gradient of the perpendicular line is the negative reciprocal. So that's obviously, if that one was positive, I make it negative, and the reciprocal is where you flip it upside down. So now I've got the gradient for my line, the one that I actually want, so I can write that in. Finally, I just need to find the plus c. So that's the y-intercept, as we said. The way that we find the y-intercept, obviously once you know the gradient, is you sub in one set of coordinates that are on the line. And we know that our perpendicular line crosses through A. So I'm going to sub in those coordinates. Do remember to sub them in the the correct way around, because it can be quite easy to put 3 first and then minus 5, but obviously that's not correct. From there, I just use my calculator to find C. So if I multiply that together, 3/4 times 3 is just 9/4. Now, because it's negative, I'm going to add it, aren't I? So that's why I've got it positive in my calculator. So minus 5 plus 9/4 gives you, I'm just going to leave it as a fraction. You can write it as a decimal if you want, but I just prefer fractions. So that's negative 11/4 for our y-intercept. And then all I need to do is just write it all together. So y is minus 3/4 x minus 11/4. No, you don't use the y2 minus y1 over x2 minus x1. The only reason for that is for gradient. Yeah, you are right. The only reason why you can't do that is just because there's not... Do you see how you need y1 and y2? We've only got one set of coordinates. We don't have 2 sets of coordinates, do we? So it's just in this particular case that you can't do that. Obviously, in some questions you can. It just depends what they gave you. They didn't give me 2 sets of coordinates, so I couldn't do it. That's the only reason. But yeah, sometimes you can. It depends on the question, doesn't it? You said where there's space on the question, but it's lined off. Can we write under that line? Don't know. Like here. I probably wouldn't, because also, again, like, why they've given you enough space that hopefully you would be able to write it in this space, and I've written my writing really big and it still fits, you know what I mean? So I would try and fit it in that space. If you run out of space, maybe try and write a little bit smaller, I guess. I wouldn't risk it, because I just don't know if they're going to scan it. They might see it, but I don't know for sure. Maybe ask one of the invigilators or ask one of your teachers, they'll know for sure. Okay. Okay, we've got 4 questions left. One of them is a 3D trig one, which you've already had 3D trig anyway. The question 18 is also a circle theorems one. So what we can do is, because we've got 30 minutes, haven't we, until you need to go. I'll do this one and then I'll work backwards. All right, part A obviously should be fine. I'm assuming part A was all right. So we've got obviously a quadrilateral here. CD is A. If they haven't labelled it for you, obviously label it yourself. DE is B, so that's the whole of that line. FC, where's that? Here is A minus B. They want us to work out FE, so that's obviously A minus B plus A plus B, but if you simplify that, you should get just 2A, which tells me it's obviously parallel to CD. Okay, this is the bit that you want to know how to do. There is a very specific method that works every time. The problem is I think the method itself is quite complicated, so it might not even be helpful anyway, to be honest. So they've said M is the midpoint of DE. X is the point on FM such that you've got this ratio n to 1. Now I'm writing n to 1 here, but that's not the vector, right? That's just a scale. CXE is a straight line. They happen to mention that CXE is a straight line, so I'm going to draw that on. They happen to mention, like, oh, by the way, this other one is a straight line. Just draw it on. Work out the value of n. Okay, the way that you do this is whenever they mention, sometimes they mention it, sometimes they don't. It's a bit easier when they do mention it. You see how here they mentioned CXE as a straight line, and you're kind of thinking, well, how is that relevant? Like, it doesn't seem to be relevant. CXE is a straight line. We want to find 2 vectors from that line. You can work out any 2 vectors from that line. It doesn't matter which 2. I normally do the whole line because I feel like the whole line's easier, and then a smaller version. So for example, I would probably work out CE and CX. You can work out X to E. You could work out the other direction. You could work out E to C, E to X, X to C. I don't care. Just work out 2 vectors from that line. Okay. N over, exactly, yeah, you're right, Bob, yeah, it is. Okay, we'll get to that. Yeah, so you want to, what it is in this question it's a bit more obvious because they've mentioned the straight line, but in some questions where they don't mention it, you want to figure out which line, even if you have to draw it, crosses through the one that I'm interested in. Obviously, the one I'm actually interested in is this one, isn't it? Because that's the one with the ratio. That's the one in the question. But which one crosses through that? Do you see how, in this case, CXE crosses through? So you're going to try and find that. Yeah, Bob, I replied to you, it is that. I said you're right. Okay. So I'm going to find out CE and CX. You can find out whichever two you want from that straight line. I don't really mind which two as long as it's from that line. So for example, the first one is easiest, isn't it? Like CE is the easiest one to do. C to E. Thinking where to write it so we can... I'll write it up here so I can at least keep it all together. CE, that's pretty straightforward, isn't it? That's A plus B. You might as well just write that. Even if you didn't know that you needed to write that, you might as well just write it, because my advice for if you don't know how to work out these questions is just start writing down any vectors you can figure out. If you're not sure what to do, just write down any vectors you can figure out, because normally the first 2 marks is just for writing different vectors. Okay. So if I just wrote that down, you've already got 1 mark. This is a 4-mark question. I've already got 1 mark and I've not really done anything, have I? Okay, that's fine. Now think about CX. That's obviously a bit more complicated, isn't it? You could go obviously to C, you could go to D to M back here, or I'm probably just going to go down and then up because it's smaller. So that tells me that I need to know FM. So write that one down as well. F to M, 2A minus a half B. I've just gone this way along the bottom and then up. You can obviously go up and around. It's fine. So then Fx, this is where you were saying about, Bob, about it being n over n plus 1. Fx is a smaller version of Fm, isn't it? So I'm going to have Fm and then a scale factor. So how do I convert this into a fraction just as normal? The numerator is whatever the ratio is. The denominator is both of them added. So because I want the f to x line part, that's my fraction. Now the reason why I want that is because now I've incorporated the letter that I'm looking for in one of my vectors. So c to x would be, we're going the wrong way down this line. Be careful if you're going the wrong way. So that's negative a minus b plus, just make sure you can see what I'm writing. I'm not going too far. N over n plus 1 2a minus a half b. Now if you write both of these or any 2 vectors that are related to this line, you get 2 marks. You could stop at this point and go, great, I've got half marks. This is half marks. Okay. Okay. So I'm going to now expand and simplify the second one, because you see how I've got A's and B's all over the place. Expand and simplify it, get all the A's together, all the B's together. Okay, so that's minus A plus B. Be careful with your negatives and positives, otherwise it could all go wrong. 2n over n plus 1a minus n over 2n plus 2. I'm just multiplying the fractions here, right? B. And then I want to get a and b together, because this is technically a minus 1 and this is a positive 1, isn't it? So the way that I just get them together is I would do bracket, just factorize it again into single brackets. That's probably what I would do. Minus 1a. This is the bit where you don't get many marks for it, so it's kind of almost pointless. And then 1 minus n over 2n. That bit b. See how I've got something a, something b. That's what you want to do. Okay. This is when you're going to create your simultaneous equations. So you want to equate the coefficients of both lines. So you see, I know I've highlighted nothing there, but technically that's a 1, isn't it? Technically that's 1a. Now, I can't put them literally equal to each other, because look at your diagram again. Cx is a smaller version of Ce. It's not literally equal, is it? Why am I finding Cx? I literally explained this at the start. Okay, right. I'm just going to have to get rid of some of you guys because you're just being really inappropriate now. All right, I'm going to carry on, guys, because anyone who's being inappropriate, I'm just going to kick you out, because, yeah, it's not okay. All right. So I'm going to create two equations, one for the A coefficients, one for the B coefficients. So as I said, I can't make them literally equal to each other, because if you look at the lines, the vectors that we were referring to, we had CX and CE. That's a really bad line, but you get the point. They're not the same length, are they? So they're not literally equal to each other. Now, the problem is I don't know the scale of this line either, do I? I don't know this scale at all. So I have to bring in, this is a bit where I think a lot of people kind of go, this is now really confusing. I have to bring in another scale. So N is my scale for FX, FM line, isn't it? That one. That's my scale for that line. But I also need a scale for the CX line. So I just bring in X. You can bring in whatever other letter you want. I'm just going to bring in X. So you can multiply the X on either side of the equation, but as long as for both equations you stick to the same side. I normally like to multiply it on the side that's easier. Do you see how on the left that's just a 1, isn't it? So I'm going to multiply that side by X. I know that you wouldn't normally write 1x like that, but I'm just kind of trying to show where the 1 has come from. And then I'm going to do the exact same, but for the B coefficients. This one is also technically a 1, isn't it? 1b. So again, multiply your X scale. I'm going to write it here. X is, just so you know what that's referring to, scale of line CXE. That's that, just so you know. And then obviously the other side is 1 minus n over 2n plus 2. So these are my two equations. This is what I'm saying. I feel like if this point you think this is just too kind of abstract, it's not making any sense, what I would do is I would just work out just a few different vectors and then stop there. You'd normally get 2 marks out of 4 or 2 marks out of 5 anyway. All right. So from here, if you're happy to create these equations from here, then it's kind of just straightforward because it is solving simultaneous equations. Obviously, I'm only interested in finding out n. I know I've written down x, but that's just because mathematically I have to, but I don't really care about x, do I? I've not been asked about x. I've only been asked about n. So this one was quite straightforward actually, because I put the x on this side. Those are equal to each other, aren't they? X is the same as x. So I'm just going to solve my simultaneous equations now. Let me write it properly. 2n over n plus 1 minus 1 is 1 minus n over 2n plus 2. This is just solving simultaneous equations, right? All the marks work similar for AQA because there was a 5 marker in paper 2. Do you know what with AQA I thought was odd is I've not really, when I looked through all the past papers, because I have some students who do AQA that I tutor just one-on-one, when I was looking through the ratio, the vector topics, most of the time they asked for the parallel lines one. Like prove it's a parallel line, which is a much easier one. They didn't often ask about the ratio one, so I'm surprised that came up this year. So what I'm saying by that is I haven't actually seen a mark scheme for AQA on that question because I just hasn't barely ever come up before. So I don't know, but if it's 5 marks, I would assume the same. Obviously, this one was only 4 marks, but normally it is 5 marks for Edexcel as well. I don't know why they only gave 4 marks for this. I'm not honestly sure. So it probably would work the same, yeah. Maybe 2 marks for the first two vectors or some vectors that you found out, a mark for making the simultaneous equations, a mark for solving the equations, like the process, and then a mark for your answer. That's what I would assume. Yeah. So then I'm going to solve this for n. So you might rearrange it differently to me. That's okay. You can rearrange it however you want as long as you solve it. I added this one to get all the n's together at least. Add the 1 to get that on the other side. Be careful because the 1's don't cancel each other out. It looks like they do, but they don't. Okay, so you can obviously just cross multiply, you can multiply however you want. I think, yeah, I would just multiply by both denominators. Maybe you could add this together first. It depends what makes sense to you, I guess. You could multiply by just the 2n plus 2 because that one is like, this one is technically double this one, isn't it? So if I multiply just by 2n plus 2, that would cancel out everything. But again, however you want to rearrange it is fine. So if I multiply by 2n plus 2, I'll put it here. I'll just kind of write it fully, but you can obviously cancel it out. Oh, I missed the other n. That n is obviously there, and then you get a 2n plus 2. And then technically, let's say, because you can factorize out another 2 here, don't you? You get 4n. I'm just trying to over-explain it, basically. Do you see how I get n plus 1 on both? So that will just cancel. Let's expand this, 2n plus 4. So we've got 4n plus n. Like I said, you might expand it, move it around differently to how I have. Have I done this right? This doesn't look right. Hang on, let me just check my working because for some reason it doesn't look right. 2n over n plus 1 minus 1 is fine. Yeah, 1 minus n over 2n is fine. Why have I rearranged it differently to before? Add 1, you get 2. And then I added that one to the other side, yeah. Just checking out because I did this the other day and it came out fine, but I feel like this is not going to come out to the way I want it to. What have I missed? 4n plus n is fine over 2n. So I times everything by 2n. Oh, yeah. This is what I missed, wasn't it? This is meant to be 2n plus 2. This is the problem with this one, is you don't get many marks for the rearranging, but that's where it could definitely go wrong. There we go. So that's meant to be 4n. That makes sense now. Okay, fine. 4n. Obviously, collect the like terms, all of that, you should get n is 4. I was thinking I've got a number that's not a whole number, but either way, you should get n is 4. Yeah, exactly, you're right. 2 brackets, 2n plus 2. I missed out the 2 for some reason. Yep, could have cross multiplied. You can do it however you want, as long as you get to the same answer of 4 at the end. That's fine. There. But the point is, I know this is quite a lot to take in. The point is the steps are the same for each question. So step 1, you have to find 2 vectors from the same line. You have to identify which line it is. That's probably the hardest bit, I guess. Step 1 is to find 2 vectors from the same line that crosses through the one you want. Step 2 is then to create correct simultaneous equations for the coefficients of a and b. You always have to bring in a second scale as well, because obviously the other line that you worked out has a scale. Step 3 is obviously then solve the simultaneous equations. I didn't find x because I didn't care about x, but sometimes you end up finding x anyway, just depends on the question. And obviously then there's your answer. I didn't have to put it back into a ratio. Sometimes you do, don't you? I didn't have to put it back into a ratio because it just said find the value of n. Sometimes they want you to put it back into a ratio. Sometimes it's k, and then that's just your answer is less than, it'll be normally a fraction less than 1. It depends, but those are the general steps that are always the same. Yeah. If you decide, you know what, that's just not worth my time, like even if I knew what I was doing, it would still take me more than, for example, 4 minutes to do that. You might just go, I'm just going to write down a few vectors that I can figure out, and you'll probably get 1 or 2 marks anyway. Yeah. So for vectors, if you get one that you're not sure what to do with, I wouldn't leave it blank. Just write down as many vectors as you can figure out. If you're not sure how to do the rest of it, don't worry. Just write down as many vectors as you can figure out, because normally that'll be the first mark, if not the first 2 marks. So you might as well do that. Okay, we're going to go back. So we had a few topics that we had, like 3 questions that we missed. Okay, question 17. There are some small cubes and some large cubes in a bag. The cubes are red or the cubes are yellow. The ratio of the number of small cubes to the number of large cubes is 4 to 7. The ratio of the number of red cubes to the number of yellow cubes is 3 to 5. Explain why the least possible number of cubes in the bag is 88. So for this one, just think about it. When let's say you did know the number of cubes in total. Let's say you did know. If you were to share out these ratios, you would normally add them together, wouldn't you? That's 11, that's 8, that can already give you a bit of a clue. And you would divide by that number, wouldn't you? Now, because they're cubes, you can't have half of a cube. It has to be a whole cube, doesn't it? So yeah, the total number of cubes has to be divisible by 11, but it also has to be divisible by 8 at the same time. So therefore, yeah, when you're saying about the lowest common multiple, that's what we're talking about, because if it has to be divisible by 11 and 8, then it has to be the lowest common multiple, doesn't it? So you can just say the lowest common multiple of 8 and 11, or 11 and 8, doesn't really matter which way around, is 88. That would be enough explanation. Okay, so then make sure you can see that still. Yeah. So what they've actually said is that all the small cubes are yellow. So there's no red small cubes. Work out the least possible number of large yellow cubes. So the least possible number, well, you could always, I mean, again, different ways to do this. If the least possible amount of cubes is 88 in total, you can just then work out the large yellow cubes, can't you? So we could work out, let's say if we're using, you could just use fractions straight away if you wanted, or you could use obviously the 88. We want to know all the small cubes are yellow. So how many yellow cubes are there in total, I guess? That would be the second ratio, wouldn't it? Which is 5 out of 8. So that would be 55. That's yellow, but I want to know how many are large. So how many small cubes are there? They've said that all of the small cubes are yellow. So how many small cubes are there? 4 out of 11. Yeah, 4 out of 11 is, I think, 32, but let me just make sure I'm not making this up. 4 out of 11. Yep. Small. So then if you take those away, because there's 55 yellow, there's 32 small, and they're also yellow, aren't they? So how many yellow large ones are there? It should get 23. But you can do it differently to that. You don't have to do it exactly the same. I did it with fractions when I worked it out earlier, rather than using the number. So yeah. Yeah, 23 exactly. Okay, so that's 4 marks. Question 18, we've got circle theorems, which you haven't had yet. This was quite a nice circle theorems one, I thought. It's a 5 marker, but it's only 5 marks because of the fact that they've asked you to give a reason, not because it's actually like really long. So the points A, B, C, and D lie on a circle. CDE is a straight line. They've obviously given you some information that you can see. BA is equal to BD, which means it's isosceles. CB is equal to CD, also isosceles. So we've got 2 isosceles triangles. They've given us a starting point of 40 degrees for this angle up here. Work out the size of angle ADE. This one. So the only thing you can do is start with 40, isn't it? Just go, well, we'll start with 40. Because it's an isosceles triangle, I'm going to work out the other 2 angles, because these are the 2, A and D are the same angles, aren't they? So take away 40, divide by 2, you should get 70 degrees. They have said to give a reason, so you can say, isosceles triangle angles. I think normally you have to give at least 2 reasons. Ideally, obviously, mostly the circle theorems ones, but... Then from there, how do I kind of keep moving? Well, this is the bit where the circle theorems comes in. A and C, if you kind of try and zoom out in your head, ignore the line BD, just look at it. A, B, C, D is a cyclic quadrilateral. So the opposite angles add up to 180. So angle C would be 110 because of that, this one here. So this is kind of a key reason to write down. This is what they're looking for. Opposite angles in cyclic quadrilateral add up to 180 or equal 180, however you want to write it. And then from here, you've got another isosceles triangle, so you can obviously work out these other 2 angles. So 180 minus 110 over 2. which is 35 degrees. You could obviously write the same reason again, but I don't really see much point. And then finally, this is all on a straight line, isn't it? They said CDE is a straight line, so the last thing is just to work out from the straight line. So 100, it's just basically loads of 180s. 180 minus 70 and the 35. So yes, as you've said, guys, it's 75. Make sure you write down at least 2, I would say, reasons. That's probably what I would write, yeah. And there we go, 5 marks. So that one I think was quite nice, to be honest. Even though it was question 18, and even though it said 5 marks, I think that was a quite nice one. Yeah, that was a nice question. Yeah, the quadrilateral, I think that's the problem, is because there's so many other lines, you have to try and see the quadrilateral. But what I would think, this happens quite a lot in Edexcel, the quadrilateral one, I feel like happens quite a lot. So now that you've seen it, I would maybe keep that in the back of your mind and just double check if they do, I'm assuming that they will give you a circle theorems question. If you look at that on Wednesday and just go, is there a quadrilateral? Just let me double check. Because I feel like the cyclic quadrilateral comes up quite a lot with Edexcel. That one, and then the alternate segment theorem, which wasn't here, but it is in a lot of the others. So yeah, definitely, even if there's loads of, obviously looking at it, it looks like triangles, which, I mean, it is, but also the 2 triangles create a quadrilateral. So just, yeah, consider that as well. Yeah, it does come up quite a lot in Edexcel, so just be aware of that. Have I got a quadrilateral here? Because otherwise, yeah, how are you going to connect this triangle to the other one without that kind of piece of information? So yeah. Okay, the last question is a 3D trig one, which I'm pretty sure you've already had. So chances of it coming up again, I feel like, is low, but I will go through it anyway just for anyone who's interested. But this is the last question, at least, because we did, obviously, question 20 already. The diagram shows a triangular prism. The base ABCD of the prism is a square. This is something to note because I don't feel like it looks like a square, but they've said that it is a square, side length 15. So just be aware of that. It is a square. Angle ABE and angle CBE are right angles. ABE, CBE. Well, yeah, you would know that anyway, wouldn't you? Because they're both as a square and a rectangle. M, well, they've given you 35 degrees here. M is the point on DA, so this front line, such that DM to MA is 2 to 3. So, you know, roughly about here. I'm going to just draw it on, roughly about there. Calculate the size of the angle between EM and the base of the prism. So obviously I need to draw some lines. Because it says EM, I'm obviously going to draw EM. And then it says the base of the prism. So that, I feel like this is quite common as well with Edexcel, is the base of a prism, or the plane, which is normally the base. What angle is that? Because it's not this. It's not that, because that would be like a really odd diagonal slanted triangle. The triangles are normally stood upright or like flat on a surface, right? They're not normally slanted, if that makes sense. So what you have to do is, if they ever mention the base of a prism or a plane, which happens to be the base, is you draw a diagonal line across the plane or across the base, obviously relate it to your question. So in this case, it would be helpful for me to go from M and then to B, because you see how that would create a nice stood up right angled triangle going through my prism. So that's the diagonal line I'm going to draw. So therefore the angle is this, because obviously the diagonal line I've drawn is, it does go through the base, doesn't it? So from here, once you've drawn that, I feel like it's not too difficult. Obviously, I don't have any information about the triangle EMB, but I just need to find some stuff out. I think the first thing that I thought was this MB. I could work that out using Pythagoras. Obviously, don't forget that the 15 is obviously the whole of this line, so I just need a small amount of that line. So add up our ratio, which makes 5, 15 divided by 5 times by 3, because I'm looking at this right-hand side, is 9. So actually, M to A is 9 centimeters. And then from there, I could just use Pythagoras. You see on the base of the prism, that's obviously also a right angled triangle. So to find MB, just normal Pythagoras, 9 squared plus 15 squared. Now it is a decimal, so what I'm going to do is just leave it in the surd format just so that it is exact. 3 root 34. Just so I don't round it too soon. So I now know this line here, 3 root 34. Now what else can I find out? Obviously because I'm looking for an angle, I need two sides. So I've got this side. What other side could I find? What other information have I not used? I've not used the 35 degrees yet. I know it's quite hard to see because we've drawn all over it, but looking at the triangle AEB, this one on the side of the prism, I've got one side and I've got an angle. So what I'm going to do is find out this side here because that relates obviously to my other triangle, doesn't it? So you see how I've got the adjacent and I want to know the opposite. So that's obviously tan. Tan. We're looking for the opposite, so I need to do, let me label it properly, to find EB, I need to do tan of 35 multiplied by 15. Which gives me another load of decimals. So luckily I've got this as my second number. So I'll write down 10.5, but obviously it is, you know, more than just that. So 10.5. So now I can actually look at my final triangle again, the pink one. What have I got? I've got the opposite and I've got the adjacent again. So again, we're going to be using tan, but this time we're looking for an angle. So that would be tan of the angle, you could call it X, call it whatever you want, is opposite over adjacent. So the opposite was the 10.5, the adjacent was my 3 root 34. And then obviously we want to do tan inverse when we actually use our calculator. So I've still got 10.5 as my answer here, so I'm going to use my answer button. So tan inverse answer over 3 root 34, because luckily that is an exact number. And then you get this. Now they have said to one decimal place, so yeah, you're right, it would round to 31.0, because you still need to write a decimal, don't you? 31.0. 31.0. Yeah. So yeah, and obviously as you've seen, we've done the final question anyway. So yeah, that was pretty much everything on that paper. Yeah, thanks guys for joining me today. Hopefully you found it helpful. I'm probably going to do another one tomorrow, which will be the paper 3 of this year, so June 2019 paper 3, and maybe one on Monday as well. On Monday, my predicted paper will upload as well, so you can have a look at that. Although do have a look at the predicted paper 2, and just any topics that have already come up, just ignore those. But there were quite a few topics in my predicted paper 2 that didn't end up coming up. So those I feel like are now going to be on paper 3. So you can have a look at my predicted paper 2, which is just as a normal video on my channel, probably 1 or 2 videos ago. So just scroll through my channel, you'll find that. That could be helpful as well. But yeah, otherwise, thanks for joining me today, guys. And I will see you hopefully tomorrow.